Hi guys, it's Mr. Knight here for Algebra 1. We are going to be looking at the other rules, the last couple rules for working with monomials. So if I'm dividing monomials, you might see something like 4x squared divided by like 2x to the first power, just like that, okay? And there's two steps to do this. The first thing we do is we actually divide the coefficients if it's dividing. So if we're looking at this example up here, we look at our coefficients. 4 divided by 2 is 2. And then I need to use this quotient rule to simplify these guys. Well, before, if we had 4x squared times 2x, well, we go ahead, we multiply the coefficients and get 8. And then we look at our exponents for our variables. And this is going to be x to the 2 plus 1. Right? So this is x to the third. Well, if division is the opposite of multiplication, then the opposite of addition will be subtraction. So when it comes to the quotient rule, we're actually going to be doing something like this. If I have x to the m power divided by x to the n power as such, then this turns into x to the m minus n power, just like that. So that is the quotient rule to simplify the exponents. So let's go ahead and go over a couple of examples. If I am talking very quickly, then you should pause the video and write this stuff down and rewind. Okay, so we're looking at, let's look at number 2, for example. I got k to the 8th power divided by k to the 3rd power. Again, no coefficients, we're good, but we do have exponents, so using my quotient rule, this is going to be k to the 8 minus 3 power, which is k to the 5th power, and that guy is complete. It also works with multiple variables. So if I'm looking at number 4 right here, I have a to the 6th times b to the 4th all over a to the 2nd, b to the 3rd. Again, I'm going to look at my a's. So I'm going to do 6 minus 2, get a to the 4th. I look at my b's. I get b to the 4 minus 3, which is b to the 1st. That guy is done. Okay. We look at number 6 now. Now we actually do have a coefficient. 14 divided by 7, that is 2. And then I look at my x's and my y's. Okay, this is x squared over x, so that is x to the 2 minus 1, so x to the 1st. This is y to the 2 minus 1, so y to the 1st. That guy is done and divided. Okay. You also need to keep your signs in mind. So if we look at number 8, for example, we have a negative divided by a negative, so we'd get a positive 5 out of that guy. And then, again, exponents. X to the 6th over x to the 5th is x to the 1st, because we are subtracting based off our quotient rule. Y to the 5th over y to the 3rd is y to the 2nd. And now we have just z just chilling right there. That guy is done. Number 10, 36 divided by 54. It doesn't divide nicely. You got to treat it kind of like a fraction and reduce it. So what can go into 36 and 54 evenly? The correct answer is 9. 9 can go into 36 4 times. 9 can go into 54 6 times. Well, it looks like we also have 4 and 6. We know that 2 can also go into those. So if I put 2 into 4, that's 2 times. 2 into 3 is 3 times. So 36 over 54 has reduced to 2/3. And then the exponents will do the same thing as we were doing earlier with the quotient rule. This will be x to the 9 minus 3, which is 6, y to the 5 minus 2, which is 3, and that guy is done. Okay, go ahead and flip your page if you printed this guy out or if you're taking notes. We are just going to continue on to our final last exponent rule, which is negative exponents. If I have x to the, let's call it the negative m power, just like this, we are allowed to have that, but we need to, in order to actually get it to be positive, what we do is we actually put our x underneath in our denominator, and now we raise it to the positive m power, just like that. It also works the other way. If I have 1 over x to the negative m, just like this, and I want to make it positive, I can just make this x to the positive m power, just like that. It works both ways. Okay? So our goal for these ones is to simplify them just like normal, but we're going to try to have only positive exponents. We might also have other rules in store for us that we need to keep in mind. Okay? So let's try a few. Let's look at number 5. We have 3x to the 3rd power, and that is also raised to the negative 2 power. This reminds you of the power rule, because the power rule means if we have an outside exponent, well, I need to take it and I need to multiply it to the exponents here. I also have to raise my coefficient to that outside exponent. So this turns into 3 to the negative 2, and then x to the negative 6. Again, if I would like to make them positive, I need to put them from the numerator to the denominator. So this will be 1 over 3 to the 2nd power, and then x to the 6th power. And we know what 3 to the 2nd power is. 3 times 3 is 9, so this answer is 1 over 9x to the 6th, and that guy is complete. Let's move on to something like number 8. This time we are actually multiplying some monomials. We have a to the negative 5th, b to the 8th, c to the negative 12 times a to the 7th, b to the negative 3, c to the 7th, just like this. Now, my product rule tells me I am going to add those exponents. Okay, so negative 5 plus 7 is a to the negative 2. b is 8 minus 3, that's going to be b to the 5th. And then c to the negative 12 plus 7 is c to the negative 5. Now, only some of those guys are negative exponents, the a and the c. So I can put them underneath the b, and it'll look like b to the 5th over a to the 2nd, c to the 5th, just like this. And that guy is complete as well. Let's look at number 12. Number 12, we actually do have k to the negative 2 over k7. Again, I want to make this k positive, so I need to put it in the denominator. Now when I do this, I'm going to get 1 over k to the 2nd power times k to the 7th. They are next to each other, and again, my product rule tells me to add those exponents, so this is 1 over k to the 9th power, and that guy is completed. This is Mr. Knight signing out. Hope you took notes on this stuff.